Kia ora whānau. In this video we are going to be looking at inverse normal problems. This is when you are given a probability, or it could be a percentage, and you're asked to work out a particular value of interest. We're going to be looking at three cases. Case A is the greater than case, or let's call it the right tail, as is drawn in the picture for you in the green there. Case B is the less than case, or we're looking at the left tail. Case C, we're looking at what I like to call the central case. So, here is the scenario. The weight of a pukeko is normally distributed with a mean of 900 grams and a standard deviation of 40 grams. The first question we're going to ask is, what is the minimum weight a pukeko has to be in the top 10%? So in terms of your sketch there of the normal distribution, using the information that we have, I know that it's going to be the greater than case because I want to look for the top 10%. So I've shaded in that part in the green there. I've also put in there my mean of 900 and standard deviation of 40, just so it's clear and I can refer back to it when I need to. Alright, so how do we go about solving this problem? So there's my 10% probability there, or 0.1, and I'm looking for that value there. So typically when we're calculating a probability using a normal distribution, we're actually given that question mark, the mean and the standard deviation, and we're asked to find the probability in the green. So hopefully it's a little bit clearer about what you're trying to do here. Alright, so to press on, what we need to do is consider this relationship here. Z equals x minus the mean over the standard deviation. So before I continue, I need to do a little bit of algebraic rearrangement. So this x value is equivalent to my question mark. So this is the value that I'm eventually wanting to find to solve this problem. Now the z value is the equivalent value of the x value, but it is in the standard normal distribution. So just to recap there, in the purple there, the x value is to do with the normal distribution, so the x distribution if you would like to call it, and the z value is to do with the standard normal distribution, where your mean is 0 and standard deviation is 1. So we need some of these values to help us find the problem. So let's press on. So I'm going to multiply both sides by the standard deviation, and when I simplify, I get this. Next step is to add the mean to both sides, and then I'm left with this. So what you want to remember, or the rearrangement you want to remember or understand how to get to, is this one here. X equals the standard deviation times z plus mean. So let's actually see how this works. So firstly, I need to find my z value. How do I do that? Our standard normal distribution table will assist us here. So remember, when you're using the standard normal distribution table, this is the probability that I've just colored in the orange is the one that I need to consider. Because if you look at the sketch in the actual table itself, it only shades in or considers that the probability between the mean and a value. Okay, so what I have to do here is take 0.5, which is 50% of the distribution, and take away the 10%. And what I'm left with is the 0.4. So the 0.4 is the probability there in the orange, or the orange shaded area. Now let's look it up here. So the closest value I can find is 0.3997. Now as a rule of thumb, what you should do is look up the value which is doesn't overestimate, but is just below the probability that you want. So it's just below the probability that we want. What we need to do is, though, add this number there to get as close as possible. So what we're going to end up with is 0.3999. When rounded, is 0.4. So what is my Z value? There it is, 1.281. So we're almost there, guys. So we're going to use our formula there that we found before, and we're going to substitute some values in. So that's the standard deviation there, 40. We're going to multiply the Z value that we've found, 1.281, and then we're going to add the mean. And therefore, the value of interest that I want is 951.24 grams. Now there's an alternate way to do this as well. And we're going to consider the same situation, but in your graphics calculator or in an equivalent sort of device here, you can find the inverse normal function. Once you've done that, what you can do is enter in the values of interest there. So we've got my right tail, because I'm looking at the right hand side of the graph. I've got the area equals 0.1. For the 10% there, my standard deviation is 40, mean is 900. So just highlighting a few key parts there for you, and I get an answer there. So the answer is telling me that I'm approximately looking for a value of 951 grams. So now let's consider another scenario. It's obviously correct there. So we're looking at the same pukekos who are normally distributed with a mean of 900 and a standard deviation of 40, but this time we're going to ask the question, what is the maximum weight to be in the bottom 15%? First thing to do, before we do that, this is the less than case, and the first thing we should do when we're faced with a situation like this is sketch what we know. So the mean and standard deviation are as before, but we're looking at that left tail there in the green. So let's find the Z value. Alright, here we go. So what probability do we need to actually look up in the body of the table? Well, again, it's that orange bit there. And we get that by taking the 50%, which is half the distribution, 0.5, subtract 0.15 from there. So what we're looking for is 0.35. So what is the closest number we can find in the body of the table there? 0.3485. Now in order to get as close as possible, we need to add, let me go back one, that number there, 14. So we'll end up with 0.3489, which is the closest we can get there. Alright, so our Z value now is 1.036. Now we're going to use our formula. We're going to go 40, which is the standard deviation, and we're going to multiply by negative 1.036. And the reason is, if you think about our standard normal distribution, anything to the left of the mean is going to be a negative number. That's why that Z value there is negative. So if, in general, if we're below the mean and we're looking at our Z values, they're going to be negative. Add the mean of 900 that we have in our distribution, and we get an answer of 858.56 grams. Equivalently, what we can do is use our graphics calculator. Again, select the inverse normal function. This time selecting the left tail, entering 0.15. Our mean and standard deviation are as before. And there's our answer there of 859 grams. That's rounded for you guys there. So, alright, we got one more case to consider. So the situation is as before, but this time we're going to ask, what are the weight of pukekos in the middle 25%? Let's have a look at what this looks like. So we're looking at the central case here. Here's the picture. Our mean of 900, standard deviation of 40. And this time, we need to play around a bit with our percentages here. So we're looking at the middle 25%, or 0.25. But what I want to do first is I want to divide that number by 2. So I get 0.125, or 12.5%. Now, how does this help us? Well, that 0.125 is actually half of the shaded area. So 2 halves make a whole. So hopefully that's obvious enough for you. And we're looking for that value there. So let's do that first. So let's find our Z value. Here we go, that's the closest we've got so far. And what we need to do is add another number there. And here is our Z value, 0.319. Alright, so there's our little formula. And we get an answer there of 912.76. But we're not done yet, because if we are considering the central case, we need to think about the value to the left-hand side of the mean as well. So that's number 2 there. So remember, when we're looking at a Z value which is to the left of the mean, it has to be a negative number. So hence why we've gone 40 times negative 0.319, adding the 900 on, and we get an answer of 887.24 grams. So in order to answer this question, we need to think about which value is the lightest weight of the pukeko and which value is the heaviest. Now equivalently, we can do this on our graphics calculator by using the inverse normal function, this time selecting central as our tail, and the area in the middle is 25%. And there are our answers there, 887 grams and 913 grams. Thank you for watching.